Okay, so today we're talking about graphing exponential functions for 5.3a. And first, we're just going to do a quick review on the laws of exponents. These are the laws that you guys learned in Algebra 2, and we're really expecting you guys to know how to use them. So this is just a quick review. We have these in your notes, and we will be expecting you to know how to use them throughout this chapter at least. Okay. So they're really just the basic ones. We can talk about this more if you need extra help, but they are there to kind of guide you. Okay, so exponential functions. We're going to start with the most basic form of exponential function, which is a raised to the x. Okay, so we have the case where a is larger than 1. For example, we have f of x is equal to 2 to the x. Okay, so we're looking at when a is larger than 1. And we picked 2 because it's the easiest one. We'd have like 1.5 or 3 or 100 to the x, but we picked 2 for the most basic uh, parent function. We call this the parent function because there are no transformations on it yet. So we're gonna explore how this work. Okay, so we're gonna plug in some numbers. So I put 0 for x in the middle because I want some negatives and some positives around my function. So 0 goes in the middle, and when I put 0 for x, what do you think I get for y? This is 2 raised to the 0. So 2 raised to the 0 is just like anything else raised to the 0. Anything raised to the 0 is going to be 1, right? That's one of the laws of exponents. Okay, and then we go up to 1 raised to the when 2 raised to the 1 for x is 1, that's 2. 2 raised to the 2 is 4. 2 raised to the 3 is 8, and so on. And then we go to the negatives. 2 raised to the negative 1. And when you have negative exponent, that means you're basically dividing, right? So I have 1 divided by 2. It's 1 half. And then negative 2 means 1 divided by 2 times 2, which is 1/4. Okay, so plotting this on the graph, it looks like this. And my point, 0, 1 is there. Um, the 0, 1 is I guess is the key point in the graph. Okay, and you guys will see why. And we really want to make sure that we know that point when we graph them. Okay, so anyways, this is a is larger than 1. The case when a is larger than 1, we call a the growth factor. Okay, this is an exponential growth. So the domain for all exponents or exponential functions is always going to be all real numbers, so we don't have to worry about domain. The range, you kind of have to look at the graph and see, oh, where does it end? For a parent function where we're not shifting it, it's going to be y equals 0 for the asymptote, right? Because you see that as x gets larger or more and more negative, when I go really high negative, the x value becomes I'm sorry, when the x value gets really far into the negatives, the y value gets closer to 0. So you have your asymptote at y equals 0, and the range is going to be anything above that, so y larger than 0. The three important points, you want to write this down, three important points is always going to be negative 1, 1 over a, because when you put in negative 1, you get 1 over your a value. And then you put in 0 for x, you get 1 always. And you put 1 in for x, you get a always. Okay, so those are the three important points. That's kind of like our formula. Write this down. We're going to use them every single time. So in this case, you get negative 1. 1 over a is 1 over 2. 0, 1 is always 0, 1. And then 1a is 1 comma 2. So those are our points, okay? So it kind of gives you the shape of the exponential graph. And exponential graphs is always going to look like that. It's going to be a huge curve. So having those 3 points guide you in what the graph looks like. So we're going to talk about the case where a is less than 1, but still positive, okay? We can't graph when a is negative, okay, because that becomes an alternating function, and that's something that's going to be very difficult to deal with. So we're going to talk about when a is something less than 1 but still positive. So like I have 1/3 to the x. Okay, so again we plug this in. If I put 0 for x, remember if you put 0 for x, anything to the 0 is 1. So 0, 1 is always going to be there. And then you put 1 in for x, you get 1/3. 2 in for x, you get 1/9. 3 in for x, I get 1/27. But negative. What happens when you put negative in for x? You actually divide 1 divided by 1/3. 1 divided by 1/3 is going to be 3. -2 for x is going to be 9 then. Okay, so again, operating on exponents, you have to know these rules, and we expect you to know them. So again, the graph looks like that. Our three important points are -1, 1 over a, so 1 over 1/3, which is, oh, there's 0, 1 is always there. And then -1, 1 over 1/3 is 3, right? That's why I have -1 and 3. And then the other point is 1 and 1/3. 1 and a is 1/3. Okay. When a is less than 1, we call this a decay factor. So we call this an exponential decay, or a decreasing function. The domain is all real numbers again, and our range is y larger than 0. Our horizontal asymptote is y is equal to 0. Now, we're going to talk about all the transformations that they could apply to these functions. Okay, so again, let's look at all the a, b, c, h, and k, just like when we talked about the transformations on our quadratic functions. So there are two types of functions, right? The ones that applies to x would be your h and your b. I colored them in red so you can see how they work. So the ones in red are the ones that apply to x, and the ones in pink are the ones that apply to y. So there they are. C is the vertical reflection, and stretch and compression. K is the vertical translation. So vertical means it applies to your y values, and then the ones in red, B is the horizontal translation, H is the horizontal reflection, and stretch or compression. Okay, so let's remember what they do. The um, the pink ones, the ones that apply to Y, are straightforward. You just multiply by C and then you add by K. But the red ones are kind of opposite of what you see. You divide by B, and then you add by H, but here it says subtract H. Okay, so if you see a negative number, you actually add. You see a positive number, you actually subtract. So the ones that apply to X is always done opposite of what it looks like. So let's actually practice that. First example, I have -2 to the X. So to simplify this, there's a -1 times 2 to the X, right? So the -1 is actually your C. C is a -1. So your parent function is 2 to the x. So 2 to the x, I'm going to do the three important points. By the way, the a is larger than 1, so it's going to be exponential growth. Um, and three important points are -1, 1 over a, 0, 1, and 1a. So in this case, I get -1, 1 over 2, 0, 1, and 1, 2. And then after that, I'm going to put that on the graph, and then uh, the horizontal asymptote is, of course, y is equal to 0 without the transformation. It looks like that. That's the parent function, right? This is the parent function without the -1. And then I'm going to apply the transformations. The c equals -1. That is my vertical reflection. No stretch, no compression, right? Just a reflection because the number is 1. So that means that all my y values get multiplied by -1. All the y values gets multiplied by -1. So I take 1/2 times -1, 1 times -1, 2 times -1. And my three important points now with the transformation are -1, -1/2, 0, -1, 1, and -2. Okay, so there they are. I have those 3 points, and I can see now the shape of my graph, right? My horizontal asymptote has not changed because I have not shifted the graph up or down at all. So the horizontal asymptote stays the same. And there's my graph just based on that the 3 points. Domain is still all real numbers, and range is y is now less than 0 because it goes down. Here is another example. I have 3 to the negative x plus 5. Now let's see if we can pick out what C and B and H and K are. Okay. So I got B to be -1 because that's multiplied to my x there, and K to be the 5 in the back. And my parent function is just 3 to the x. Okay, so 3 to the x and then -1 for B and 5 for K. So again, here is A larger than 1, so it is an exponential growth. My three important points are -1, 1 over A, 0, 1, and 1A. So in this case, I have -1, 1 over 3, 0, 1, and 1, 3. So those points, there it is. I have my horizontal asymptote at 0, and then my graph goes that way. That's the parent function. Again, guys, the horizontal asymptote at 0 is for the parent functions. And then we have to wait and see after transformations, see if it moves up or down, left or right, and then we'll see, oh, does it change the horizontal asymptote? Okay. So let's apply the the transformations. Okay. So B is the one that's applied to x. So I have -1. That means I have a reflection. That means that x gets multiplied or divided by -1. X gets divided by -1. And then I look at the k. K is 5. It means that it shifts up 5 units. That means y gets added by 5. So I apply those transformations. X get divided by -1. So negative times or divided by -1 gives me a +1. And then 0 times -1 is negative or 0, and then 1 divided by -1 is -1. And then the same thing for the y. I add 5 to it. I got 5 1/3, 6, and 8. So now my graph looks like that with those 3 points. And the horizontal asymptote, you see how it shifts? The graph gets shifted up 5, right? Y was 0, now y is 5. So my horizontal asymptote is at 5 now, and my graph looks like that. And domain is all real numbers. Range is y is larger than 5. Another example here. Let's pick out our numbers here. Okay, so B is just 1. There's no H, but I do have a C and a K. So C is 2. K is, well, -5. Why did I put -4? Should be -5. K is -5. Um, the parent function is 1/3 to the x. Right, so in this case, a is less than 1, so it's exponential decay. My three important points are -1, 1 over a. So that gives me -1, 3, 0, 1, 1a, which is 1 and 1/3. And then we plot that there. It looks like that, right? And y equals 0 still. So there's the graph. That's the parent function. And then let's see what happens with the transformations. I get c is 2. That means a vertical stretch of 2. No reflection. And then k is -4. It shifts down 4. So let's apply that to the y. The y values then in this case gets multiplied by 2 and subtract 4. I guess I followed through with a mistake in making it 4 instead of 5. Whatever. Um, so y gets multiplied by 2 and subtracted by 4. So all the y values I multiply by 2 first and I subtract 4. Okay. So my first point is negative 1 and 2 because 3 times 2 is 6 minus 4 is 2. And then 0, 1 times 2 is 2 minus 4 is -2. So 0, -2. And then the last one, 1 1/3 times 2 is 2/3. 2/3 2/3 minus 4 is -3 and 1/3. Okay, those are my 3 points. Plot that out. It looks like that. And then um, the horizontal asymptote was y equals 0, but y gets multiplied by 2, which is still 0. Subtracted by 4, which is that now at -4. So y is equal to -4 as my horizontal asymptote. So it looks like that. Now I just follow that and graph. Domain is all real numbers. Range is y is larger than -4. And that's it. Solving equation we'll save for Wednesday.